name is Stefan Frenzel. I'm heading the data center decarbonization group. I also have been heading the OCP and MEA community for more than 4 years, and I'm happy to be here.
Yes, my name is Henrik Borling. I'm the Business Development Director for the Nordics of Huawei within the Datacentres Ireland. And we will also hear that I'm really dedicated and passionate about standardization as I represent Denmark for the year 5600 standard, and also are present in some global committees within ISO. Thank you.
So you can see we have a panel of what I'd say industry experts with a lot of knowledge on cooling. And cooling is, it's pretty much the most important part of a data center. Without cooling, nothing else will survive, nothing will work. But the challenges now are what happens currently and what's going to happen in the future. And this is going to, it's going to be a very interesting discussion. But what I'm going to do, just to open up the discussions, I'm going to probably take you on a little bit of a history lesson on where, how we've come to today and where we've been. I've been in the data center cooling industry for 40 years. I started in 1984 as a service technician working for the Liebherr Corporation. And my first introduction to a data center, it resembled like a film set from the Starship Enterprise, from like a Star Trek movie. And you just had disk drives chugging away, randomly positioned within the data halls. You had people working within the data halls, constantly changing the disks. And in them days, the air conditioning was just this noisy thing in a corner that kept breaking down. Okay, so it was great for service organisations, constantly going in, fixing them, repairing leaks. And also in those days, humidity was very important within these spaces. So you used to have very, very cold data centres, running at around 20 degrees C and even lower. And then you had steam humidifiers pumping moisture in, to keep the humidity levels up in order for the disks not to warp and to survive. And so you can imagine that energy wasn't even thought of. The energy bills must have been absolutely huge. Where the major heat started to come in was probably in I'd say the early 90s. And this is where servers first were introduced into legacy data centers. And these servers created one of the first problems with heat density. So you had traditionally rooms that were just flooded with air. 9 times out of 10 you'd have a raised floor. The housekeeping under the raised floor was appalling. You just had bundles of cables, trunking and all types underneath the floor. And as we kind of all know, that air would just take the least path of resistance. So the air wasn't getting to where it should be going. And now introducing some of these new server technology into legacy data rooms, the biggest challenge was how we get the air to the right place. And that was the big talk in discussions at that time. So, and as we move further in to the late 90s, coming into the year 2000, this is where the dot-com boom started. And this is where data center owners and designers were actually building data centers that resemble what we know today. This is where you had like uniformed lines of units, it was the start of what we see today. However, and this is a big however, the dot-com boom was slightly similar to what we're talking about AI today. The dot-com boom, you had investors building large data centers, because the talk was everybody was going to be on the internet, everybody was going to be buying things and everything else, and it didn't quite happen that quickly, to the point that these data centers were closing. Okay, so it took a number of years to get things moving again. So now we're going to around the 2010. 2010 is now resembling what we see and know today. This is where pretty much everybody on the planet now owns a smartphone. There's people downloading things, there's apps, there's games, there's everything else going on. And the data center is now is moving thick and fast. And the heat is just getting bigger and bigger and bigger and bigger. And then other dilemmas is how do we control this element? And this is where closed aisles came into play. And even with the closed aisles or the aisle containment, the big dilemma that went on for a few years was, do we contain the hot air? Do we contain the cold air? What do we do? And the answer was a mixture of just about everything. So welcome everyone to 2024, where we're now in this situation where AI, or the rise of AI, is on everybody's lips. You know, there's new words within the cooling industry that, you know, things like fan walls, immersion cooling, on-chip cooling, all of these new words, you know, coming out. So I think it's time that I ask you guys some, I believe, important questions to see where we go. So I'm going to hand over. I'm going to just hello. Right. So I'll sit down for this. Right. The first question I'd like to ask you is, what difference do you guys see within data centers to cope with today's workload?
Yeah, do you want me to start?
Yeah.
So, without a doubt, we've given a very granular explanation of heating and cooling in the data center. It's a very simple explanation. I'm trying to keep my explanation as simple as that. So the big problem that we have is that the data centers that have been exploding in building and development with a huge amount of money being invested in them are faced now with a step change. If that step change had been visualized when these data centers were being built to cope with these new NVIDIA chips, which have only a 62% efficiency for air cooling, if people had seen this before they designed the infrastructure for the data center, we wouldn't have the white space of data centers in the same development phase that it is now. And the big challenge that we have is that the major hyperscalers and the colos, they all must adopt a way of being able to bring these AI chips, these new NVIDIA chips, into the existing infrastructure. And what we're seeing is a massive step change in an industry that isn't extremely innovative. It's not known for its innovation. The data center industry would say something like, we're all very interested in innovating as long as that innovation has been around for 20 years and tried and tested, right? So what's happening is that we have to find a way, similar to the dot-com boom, to be able to adopt the infrastructure and the data space to be able to take those NVIDIA chips, which are GPUs instead of CPUs, so at times they run far hotter. And we need to find some way of being able to use them today in an existing infrastructure that wasn't built with that level of design in mind. And I think that's the biggest step change that's faced this industry for a very long time.
Yeah.
Agree?
Yeah, I think the big thing that we were talking about was, and you hit it on the head, is the infrastructure. And we look at it in the U.S. and Americas. You know, we have colos and hyperscalers. They're building new big facilities, and we look at Europe, and you have white spaces that are already built. They've been established, and now how do you bring in that AI and the load on the data that the data is bringing both in electricity, and then in how do you get those GPUs away from those chips? And this is where we're seeing a lot of companies that are coming up with a structure of adding a module. And so it's outside of the white space, but it's incorporated, but you still have to have that load of the electricity to it. So from our perspective, what we're seeing is there's a combination of things that have to happen between current white space, proposed white space, and then in the advent of AI and these loads that are coming, and we're seeing, and right now we're talking about supercomputers going on in the US right now. There are several companies that are coming out with very brand new designs for CDs to help manage this load. And now how does a data center owner, you now have to incorporate 6 more pieces of equipment and get the load off of that, get it back into the building side cooling system and get it out. So what we see is now you have engineers that have to design dual systems that are N+1, N+2, and then you look at like some colos that we're working with that they want to be tier 2, but they have to go to tier 3 just to cope.
Yeah, Brendan, many thanks for the flashback. I think it's really good to see that there is an evolution did happen. The evolution did happen, but it's also now, as when we talk about the cooling landscape, it continues to evolve. Yeah. Of course, what we also said in the preparation to this session, the majority of data center sites worldwide are still air-cooled. Yeah? But of course, if we know liquid cooling is really now coming in due to the AI application, the high-performance application, we must say these data center sites really work with the technology from the past. Yeah? They work with the technology from yesterday. Also, the hyperscale data centers, due to my responsibility at OCP as a voluntary leader for the EMEA community, I have a good connection with these guys. And if you look in the US, I mean, Northern Virginia, for example, with the highest density of data center sites worldwide, they're all air-cooled, and they're all really old school, fossil fueled and so on. So I'm really can recall what Henrik and myself discussed. There was back in Denmark, there was a guy from Google, and he was communicating in his PowerPoint, Google, we are net zero, which is completely nonsense, you know. However, I can see it's changing. There is no rapid or sudden shift. It's continuously changing, and this is driven again by the greater need for efficiency. Sustainability is playing a big role, and really to be able, in modern data center sites, to handle the power density of these AI applications. So, yeah.
Yes, I just want to follow up a little bit of what has been said. We were at the OCP summit in San Jose for some weeks ago, and this is also when we talk about cooling solutions. We see it is. We have heard about cooling, liquid cooling will be there, and it is. But then we also see what kind of cooling solutions are we looking into. For instance, we have 1- and 2-phase immersion cooling. We have cold plate, on-chip cooling. So these things, and in my opinion, we are in a break where we are breaking things. So I don't think that one solution is better than the others. We need to look at what applications is running, and then we are looking into hybrid solutions for how we can involve these cooling solutions. And this is to divide it into cooling production and cooling distribution. If you do that, you can make it modular and scalable, also in co-location for solutions.
So it's very interesting indeed. So how do you see the direction of travel? What do you think is going to be happening within new designs in data centers, and what type of cooling is going to be introduced, and why?
So I think that one of the things to say straight out is that the hyperscalers have all come out and coalesced around a single idea. They profess a lot of faith in immersion cooling, and they think that ultimately that may be the direction of travel. But the point of the first question was to talk about the infrastructure and what needs to change. And if you look at what's happened, so I made a big point of saying, you know, when talking to you on the podcast, made a point of saying that it's only from listening to how the industry as a whole has dealt with these challenges in the past, that we can try to divine how the industry might respond in the future. And whilst the hyperscalers have said that they want to look at immersion cooling, they're pretty much doing that because of the experiences of things such as the data mining, cryptocurrencies and people like that who build smaller systems and are able to dissipate heat in a more condensed way. But they don't have the infrastructure of a large-scale data hall. And that's the big thing that we have to try and find a way through and navigate through. And when I started the podcast, what I was trying to do was, every time somebody came to a decision, a bifurcation almost, it was to help them understand the implementation of each of those decisions so that they could make an informed decision about what they wanted to adopt. And cold plate technology is moving on, it's doing where it needs to be. The OCP is doing wonderful things in preparing a set of guidelines by working with manufacturers so that they may be adopted by colos and hyperscalers and ultimately become a standard for a lot of these things. But there's a journey there. And if the journey finishes with immersion cooling, that could be quite a long way down the track, say.
I think that's actually what we see, and I think I can be a little more granular, saying that immersion is the ultimate goal, and because of setbacks with resonance and fluid and things like that, that these are things that sector of the industry needs to overcome. But in the grand scheme, the most efficient right now are cold plates, are CDUs, are the current means, and manufacturers that can meet those things are the ones that are, they're the ones that are in OCP, they're writing the white papers to establish those products as the current standard. I see, I'm like you, as an optimist of seeing where this technology goes. The density that we see in bit mining really stands out to us because we do work with quite a few of those, and the density that they're able to establish and get that much heat, those BTUs out of the fluid and get that fluid back in, and are able to, and we were talking about overclocking GPUs, they're able to overclock those bit miners to be able to get more done and only use a substandard of those bit miners to actually mine for their energy costs and be able to be sustainable for the rest of their mining industry. So that's where we want to see it go, because it is a very viable solution. Right now, it's like we're talking, right now the standard is, and it is stated as saying, direct-to-chip is the standard. This is what we're going to do. If you're going to be in our space, this is what you have to do. So.
Yeah, coming back again, I think we all know majority is still air-cooled. This is still happening. Of course, now the transition to liquid cooling is happening. Again, not as a sudden shift, but really gradually now changing. And there are certain factors where it makes sense. And what I said, yeah, we have still the old school traditional ones, but we have now, since, let's say, the trend is there since 2.5, 3 years when it comes to AI, parallel, I can see the growth now of really dedicated AI data center sites where, due to the, let's say, the density needed in that rack, or the density in those rack, the tower of power density, you need to do something because air cooling is at its limit. At a certain threshold, you cannot air cool anymore. There will be some hybrid racks, for example, yeah, when you talk about direct to chip, yeah, so the servers are direct to chip, but there's still, let's say you have the memory and storage, this remains to be air cooled, for example. We do not know when we talk about direct to chip, but when it comes to the emergent cooling, and I think we are all aware at the moment it's still a niche, right? In my humble view, I think it will scale. The tipping point we all don't know at the moment. It can be just to be around the corner. It can be another 2 or 3 years. We don't know. Again, liquid cooling is around since decades. It's really some specific computer applications, now we can see the revival driven by AI. Yeah, it's not only a buzzword invented by Silicon Valley; it's really happening. Yeah, and especially if you're in the US and talking to these guys, talking to the OCP community, we could see racks with 150 kilowatts, 200 kilowatts for next year. At the OCP Global Summit in San Jose, they announced already a rack with 300 kilowatts. I mean, think about it. Brendan, you come in, let's say, from the old days, 300 kilowatt in a rack. It's unbelievable that, yeah.
Well, do you know, I remember, and I'll go back to 1984 actually, and one of the first things that I remember seeing as a young engineer was an IBM mainframe computer, which was actually
mind-blowing, huh?
Yeah, and it was being called direct-to-chip, and the difference is the chip was about 10 kilowatts or something like that. But yeah, so yeah. Henrik. Yep.
Yes, I also say that the development we see within cooling, of course, is there, but we also need to see some of the benefits. We are talking about chip cooling. What we see is actually now we are on the brink where we have heat reuse. It's really something we can offer now, because we can run as high as 70 degrees in the cooling circuits, where we are cooling at 40 degrees. In the past, I know you also know it, we talked about the cold and hot iron. Today we talk about hot and hot iron. So it's only like Seppo's technician from Finland can come and work there because they are used to working saunas. So the temperature settings are so high. When we have discussions with district heating companies, it is like we ask them, do you want to buy the heat for the data centers? No, they say, do you want to buy the cooling? So this is because the value have not been so high yet, but at these new temperature settings, there is a value. And we have a very exciting project in Denmark where we actually have prices on the value for per megawatt from a data centers where we are using heat reuse. And this is where we see it in the future. And this is also, so don't look at data centers as a big consumer. They actually also make transition from one energy to another part. And this is what I see will come in the future. Also more that we look at data centers from the data center perspective. Don't do that. Look at data centers from a sector company perspective. What kind of industries do you have around data centers? How can you make the energy you use for data centers more like a circular wave, so you have like small microgrids for the data centers and the industries around it? This is what we really see is coming now. And this is at least also because of the cooling solutions available.
Yeah. So now, I think I'm just going to throw something out there. So let's talk about AI, okay? And really, it's just a very general question. So what's your thoughts, Rob?
Well, I suppose when you say what are our thoughts, one of the points that I kind of slightly would like to put forward is that cooling is a service to the chip. It's chip development that's going to dictate what we need in terms of cooling in the data center in the future. It something very well. With liquid cooling, you get the opportunity to use far warmer, far higher potential for things such as heat reuse. But I think what we need to look at before we go away from this is what's happening right now. Because what's happening right now is not a fully designed solution. What's happening now is we have an almost knee-jerk reaction in the data halls to be able to deploy a couple of servers or a couple of racks with these new NVIDIA chips. And the direct-to-chip cooling, whilst it's a proponent and it's advised by NVIDIA, doesn't capture all of the heat. And the problem that we have is where we replace the current racks with these AI racks, we're creating a huge hotspot in one section of the data center, and then we're relying on the traditional air cooling, as you rightly said, to be able to accommodate that, and it's impossible. So we're actually, I know from talking to people at Google, they were running, instead of an N+1 or an N+2, more CRAS for operational resilience and things like that, they were running at 110%, because they cannot afford now to have even the things they had in there for just in case back off, because they're under such pressure to cool that one section. And I think that that is currently the biggest challenge that we face here in Europe today. I'd like to think that we're a little bit ahead of the US in terms of our liquid cooling adoption, but that is a massive challenge right now. And there are ways to deal with that. You know? What do you think, Terry?
I'm going to contradict you a little bit on that. Because a couple of the clients that we have right now, the demand and the load for AI from their constituents, they're asking not for 1 or 2 racks, they're asking for an entire node.
Yep.
And they're going, okay, it's not 2 megawatts of cooling that they're looking for. They're looking for 6 or 12 megawatts and duplicating or triplicating that in the data hall. And they're just doing away with their entire traditional mindset. They are keeping the crops because, just like you said, you know, we talked about this. There's a 20% or so escape factor that we're looking at as just released heat that's not being captured by that cold plate. What we're trying to help in our part of the industry is saying, hey, this is all good and everything. We're moving way faster than anybody thought was possible. Especially now with, you know, it was every 2 years you get an advent in what a technology was. And now it becomes every 6 months. You know, we have the Blackwell, we have the new Rubin chip that's coming out. And all these new innovations that are, now you have thermodynamic engineers and fluid dynamic engineers. They're having to, okay, that heat plate now has microchannels on microchannels to try to dissipate all that heat into the fluid. And it really comes down to we're using a single phase fluid and its properties and how we try to maintain the equipment. And this is something that we actually talked about was how do you develop the infrastructure inside the data center for the not just you, but the data center owner to have a technician that can actually do all those things. They can do the electrical side, they can do the network side, and they can do now they're doing the CID, and they're doing all of that right down to, okay, I have to move an entire rack. This is a $120,000 piece of equipment. I have to pull that blade and put it in a different location. And nobody wants to have that responsibility. But now you're forcing this into data halls. In the US, we're seeing, if we're coping with this, what is going to happen for the European nations where you have developed white spaces in places like Germany where you were just talking, you have heat reuse projects. Okay, how are you going to implement that with all this heat rejection and find a place to put it? And there are companies here that are talking about, okay, we have solutions for that. Just having the listening ear from the data center side, we have solutions. Let's use those as viable and build a community on those concepts.
Right, Jerry. AI is there. It will not go away. What I also mentioned, since 2.5, 3 years is there. I think also here people in the audience, you're already using AI, possibly you're not aware of it, but yeah, just talking about ChatGPT, there are really some good language translation tools like DeepL, really all based on AI, so it's around, it will not go away, it will increase. And this has changed already the industry, Brendan, because where we are coming from, let's say the old school guys, the approach, how you design a data center site has really completely changed. In the past, there was the building, then you talked about, they decided on the cooling technology, then they had the hardware, and then, and then the application. Now it's changed upside down. Everything starts now with the application, and this defines the hardware, this defines the cooling method, and then in the end of the day, there's also a building needed, right, as a shelter. AI and machine learning will have play a large role, and this is a bit also good looking into the future of the data center design, really optimizing the cooling operations. Really, when I talk about predictive thermal loads, dynamic adjusting cooling parameters, and then maximizing the efficiency. Because this is something also looking ahead, back from the, let's say, traditional old school data center sites to modern ones, which are not too far away, really, which become, cooling will become even more efficient and more sustainable. Because as you also, countries like Ireland and Germany, the limited factor, when we talk about this power density, is actually the grids we're having, yeah? We need to live up to the energy, they're really energy hungry, those data center sites, and this might be the limiting factor what we're having today. So this is an integration, it's the overall design, it's the operation, where we're driven by the greater efficiency, and I can see time is also 10 minutes, okay. But yeah.
Henrik, yep.
Yes, I think I'm back a little bit back, because when we talk about AI in general, we also need to see what kind of applications is running. And in my mind, I think for AI, the companies providing AI, they are talking another language than we are. They don't understand us. So when they are making AI solutions, they have a service they want to provide. This service is then going into be a solution to undermine this service. And then this solution is going to be some products. These products we know, and this product is going to be a data center. But what we see when these applications is running, for the first time ever, the load in data centers is very volatile. And that is because how we are running AI solutions in there. But this is not a bad thing. We can actually, together with the customers, help and see how can this way we run the jobs there be for benefits for the data centers. All customers, they need to make these green reports where they are going to document how green they are. And they demand the data centers to be AAA plus green and sustainable. Why not help the data center to be that? So for instance, we have a project where we have been making an AI solution that identified an invasive salmon in Norway. And this invasive salmon is taken out of the rivers and fjords in a very humane, good way. So it's directed into an artificial lake where we can take it up and eat it, because this is a farm salmon. But now we're going to make it in Iceland also, and this is going to demand a huge AI to go through all these images from this. But from that part, for instance, this is going to be the 3 universities in Iceland running this. But when you have a researcher, he's going to start an AI. Why do he start it at 4 o'clock in the afternoon? And it had to run at high speed power to be ready at 6 o'clock. He only wants to have the data at 8 o'clock in the morning. Why not let the data center help to run it whenever we have the green energy for it, or we need to use the heat reduce or something? Help run the data when the data centers want it. Another part is, I've seen so many servers put into production where I don't know what kind of car you have, but you know, servers, they can also run in eco mode, comfort mode, sports mode, or sports plus mode. All the servers I see when they're put into production is running in sports plus mode, and no one's changed it. Why not let the data center help run the right applications and the right services from the servers? Because this is actually where we really can save energy. And when we save energy, we need to do less cooling, right? So this is also a way to see how can we lower the overall consumption for data center by running the data in the right way.
Very interesting indeed. Now, Stefan, you during you were mentioning earlier about these new numbers on heat density on racks. You know, I've heard people in the industry talking 200 kilowatts up to 350 kilowatts a rack. My question really to all of you guys, is this viable? Is this something that is viable?
I think we cannot deny it's happening. It's not happening, of course, for the mass. It's there. It's used by the hyperscalers. But again, I don't want to blame these guys. They talk about a lot of things, and they're working in the OCP community. They're really active there. At the same time, I mean, they're also profit-driven, you know. In the US, as you know, they have a lot of land there. The energy is cheap. The infrastructure is paid many times by the taxpayers. So they talk one thing, and if you look at the sites and also the new sites, they're still planning and building. It's still again technology from the past. It's there, but sometimes I have the feeling it's like the NASA or Formula One. It's there, but it's not happening in the industry. It will happen at some point, but I cannot predict when it will really be something available at scale.
Yeah, just one more point on that too, and that I think what you're referring to, Brendan, is the efforts that the OCP have had with the Catalina product with Neta and the OEV designs.
Yep.
But one of the things that I would say is that currently the best guesses from a number of people in the cooling industry from various different practices for the industry in liquid cooling to grow at a rate of 44% for the next 5 years. And it is envisaged that at the end of 5 years, liquid cooling in terms of immersive technology will account for up to 30%. So I think that if you want to get kind of figures and you want to think about something like that, it's useful to think about that for the short to medium term. I think that might give a better indication of where we might end up.
That's a really good segue of saying what we're seeing, like you said, Stefan, is in the US we have plenty of land, plenty of energy available in certain areas.
Yeah.
Right? And then it's all of them, you know, when I say them as the co-locators and the hyperscalers are creating this drive for a need for a product and AI, and then they're coming to us and saying, you need to build a solution. And and it really is that, and so that's where OCP comes in of saying, okay, to create this solution sustainably and responsibly, then we need to understand why you're choosing this chip, why we're going to need this type of cooling system, or the directed chip or immersion, whichever it may be, and now how do we implement that? How do we get those BTUs from those chips out to a free cooler, dry cooler, chiller, any of those things? How do we do that sustainably with good quality products? And we've all talked about this. It's not necessarily the cheapest product that's going to win in this situation, because that's one thing when you go and look at the requirements for, even right now, the black belt chip, wetted products, there are just a category of just a few simple things in there. Dry products, there are just a few things in there, and you have to fall in line to any one of those categories, and then you have to be part of OCP to say, okay, I fit this because, you know, because we write a white paper saying we're able to sustainably produce a product, efficiently move BTUs through fluid out of the data hall and into a device to extract that. So it really becomes something that we have to look at as saying, as a chip manufacturer, what are you doing to drive efficiency? And what are you doing to drive, hey, we need this type of product for you? Not telling the industry, okay, this is what we're going to do, you have to catch up.
Henrik, you that?
Yes, of course. There's, I also see that the thing is happening. I think you can see on my hair color, I have been in the industry for some years. And I learned one thing, never say never. I said, of course we cannot go into these densities because it's a law of physics. But I've been proven wrong so many times, so I know something will happen. And it makes me the change there. When we see white space data centers, for instance, I don't know if you see our power trucks outside. We're so proud of it. We say this is total power solution for a data center. No, it's not. When we talk of these data centers, it's only a power truck for 8 racks. These 8 racks is the half of the size of the power truck. So if when we go to densities like this, then the facilities, management, infrastructures is going to be double the size as the actual data halls. So this is also what we need to look into. It goes to take place for the facilities management, not the data.
Okay, guys, we've now come to the end of our session. Thank you so much for the information. And I think, yeah, I mean, if anybody's got any questions, just anybody.
To try and keep on track if possible, because Hugh will kill me otherwise.
Right, no questions, guys.
Well, we are still around here, so please come by our booth 260.
Yeah, no problem.
I'll get killed.
Yeah.
All right.
Okay,
Thank you very much, guys.
Thank you very much.
Thank you.